Hello, Har here, and today we're going to look at the cardiac cycle. So, we are going to learn about the cardiac cycle, explain the stages, put them in the right order, be able to explain what happens to the AV and SL valves during pressure changes, and we might think about looking at stethoscope and the lubs and the dubs in the heart. Starter, compare the location and function of the AV and SL valves. Distinguish between the terms stroke volume, cardiac output, and heart rate. Okay, so in terms of answers, cardiac output is the volume of blood pushed out by the heart every minute, and it is found by multiplying the stroke volume, which is the volume pushed out every time the heart contracts, and the number of times it will contract in the minute, or the heart rate. So cardiac output, stroke volume multiplied by heart rate. AV valve is between the atrium and the ventricle. It is responsible for preventing blood flowing from the ventricles back into the atria when the heart contracts. The SL valve is found on the exit vessels from the ventricles, so the pulmonary artery and aorta. It is responsible for preventing blood falling back into the ventricles when in what's called diastole, so when the heart relaxes. We'll talk about that though. So it's a double system. The pulmonary circuit carries deoxygenated blood, which is coming through the vena cava, going into the right atrium, right ventricle, and out to the blood. It then returns that oxygenated blood back to the heart on the left side. The systemic circuit, so going to the systems, takes the oxygenated blood from the left ventricle, sends it through the aorta to the body, and returns it through superior and inferior vena cavas on the right side in the atrium. This is a little diagram here. So each time the heart beats is called the cardiac cycle, and consists of the following. The atria will contract, so any blood that's filled passively the atria while they've been relaxed is scooshed. It's scooshed down into the ventricles. The ventricles then scoosh. We know that the AV valve will stop the blood now going back into the atria, and it will be expelled out through the pulmonary artery and aorta. All the chambers relax. As I said, the SL valve then prevents the falling back of blood that has not got over the aortic arch or pulmonary artery. The whole thing lasts about 0.8 seconds. So 0.3 is called systole. So that is atrial systole, the atria contracting, then ventricular systole, ventricular contractions. That altogether takes 0.3 of a second. And then half a second for relaxation. If you think about it, in a minute, how many 0.8 second chunks can you get into that? That's how many times your heart will beat in a minute. Two phases of the cardiac cycle. So we have systole, contraction of the heart. When you feel your pulse, you're feeling for ventricular systole. You're feeling for the push of the heart. So contraction of the heart. The atria contract first to push the blood down into the ventricles. We call that atrial systole. The ventricles then contract, forcing the blood up. That's called ventricular systole. Relaxation then occurs. So the chambers will fill with blood. Obviously, mostly, the atria will fill first. The ventricles at the bottom will fill through by the dripping of the atria. Mostly, the ventricles fill not through that initial diastole, but through the atrial systole. The opening and closing of the AV and SL valves, you can actually hear. It's very cool on what's called the Doppler to hear this under occluded flow. So you can hear it with stethoscope as well. So you can click on that link and have a go. There is a page in your booklet that asks you to describe using whatever this is, figure 12.3. It asks you to describe the lub and the dub and heart murmur. So the information is here. The AV valve closing. So the AV valve closing happens during ventricular systole. Lots of people get confused and think it is atrial systole that causes the lub. The pressure of the atrial valve closing happens when the ventricles contract and it pushes the blood up, and the AV valve goes, not happening, and it snaps closed. That gives you the lub. You then get the dub, which is when the SL valves close. So you've done your ventricular systole, which caused the lub, and then you go into complete diastole, and the blood comes down that's gone up the aortic arch and causes that dub sound. So that's the blood falling back down and closing the SL valve. You then have a silent period where the heart fills with blood. It's silent during the atrial systole, and then you have the sound, the lub sound during ventricular, and the dub during that initial part of diastole. Heart murmurs can also be heard if you've got extra tissue, or if you've had valve replacements or lots of other stuff. You can get weird flow patterns, and it can cause heart murmurs. So defective valves, failure to open or close properly, things like that, turbulent flows. This is a picture of a heart, isn't it pretty? The cardiac cycle, so this is just showing diastole, so everything relaxing, blood filling atria and ventricles, and then systole, this is ventricular systole. Atrial systole would be contraction of the atria. So these are the three things: atrial, diastole, and ventricular diastole. Everything is relaxed. Blood moving around your body, we'll refer to this later, is moving just under kind of normal pressure. Nothing is pushing it at that point, it's just moving because it's always under a bit of pressure. And so when we talk about your diastolic blood pressure, that's this part. You then have atrial systole, which pushes the blood down. Ventricular systole, which when we talk about your systolic blood pressure, that's caused by ventricular systole. That is the pushing up of the blood here. And we can see the timings, 0.1, 0.3, 0.4. So blood enters the atria from the vena cava and pulmonary vein during diastole. AV valves are open. Both atria will now contract during atrial systole. Blood forced into the relaxed ventricles. AV valves are still open because blood is pushing through it. The ring of muscle around the entrance to the atria here closes. It's not technically required for the course, but it does explain why during atrial systole the blood isn't pushed back up. Prevents backflow of blood into the veins. Then that takes about 0.1 second. Ventricles will contract. That blood will be forced up. It will open the semilunar valves because it opens that way basically, and the atrial valve, ventricular valves will close. That sounds lump, and prevents the backflow into the atria. We'll then have ventricular diastole stopping. So semilunar valves will close. That makes the dub sound when the pressure in the arteries exceeds the pressure in the ventricles, and it's pushing back down. So there's this constant ongoing pressure in the arteries, even when your heart isn't pumping. And when the heart's not pumping, that blood pressure will push down, and it will make that dub sound. The cardiac cycle begins again. So pressure changes and electrical changes, a very complicated graph. Nobody likes these things. This is a bit more simple. We don't talk a lot about what are called echocardiograms anymore, and we don't talk a lot about pressure changes. But in diastolic stage, everything's relaxed, but there's still this intrinsic 80 millimeters of mercury. So the reason it's millimeters of mercury, which seems a bit weird, is because initially when we measure blood pressure, we measured it on what looks like a big thermometer basically, and it uses mercury to measure where you are, like old-fashioned thermometers used to. It's mercury under pressure. So you get about 80 millimeters of mercury pressure and diastole. During the ventricular phase of the systole especially, you got to about 120, and then you will fall back down again, and you could take an average. So what's the average between the systolic and the diastolic? Complicated graph. So using the heart diagram, try and act it out in full. Get small children, cats, chickens, whatever you have in your house, plates, salt and pepper shakers, and try and act out the different stages of this. So the atrial ventricular systole, think about the diastole, think about pressure changes, when it's going to be really high, when it's going to be really low. Think about what the blood is doing, where it's moving, what stages the atrioventricular valves are going to be open, when they're going to be closed, what opens them, what closes them, and semilunar valves, and similarly, what opens them, what closes them, where are they? So it says complete your table, but we don't have that table. Just so we end summary question, what is meant by the cardiac cycle? What happens during atrial and ventricular diastole? What happens during atrial systole, ventricular systole? What makes the heart sounds? specifically. So what exactly makes the lub, what makes the dub? What happens when ventricular pressure exceeds atrial pressure? So to go through the cardiac cycle is the transition between the diastolic phase, the atrial systole, ventricular systole, and back to atrial ventricular diastole. Atrial and ventricular diastole, all the muscles of the heart are relaxed and it passively fills with blood because of the pressure in the arteries, veins. What happens during atrial systole? In atrial systole, the atria contracts and pushes blood from the atrium into the ventricles through the AV valve. What happens during ventricular systole? So the ventricles contract and pushes blood up through the semilunar valves. The AV valves prevent blood entering the atria. What's responsible for making the heart sounds? So the lub sound is caused by ventricular systole when the AV valves are closed, and the dub sound is caused by total diastole, so atrioventricular diastole, when the arterial pressure exceeds the pressure within the ventricles, and that is the answer to 6. What's happening in the picture? It looks like it's blood is filling during diastole. Looks like we're going through atrial systole now. Looks like we're going through ventricular systole now. So these are the answers in full to those questions. So you should know about diastole, atrial systole, and ventricular systole. In the next video, we will look at the conducting of the heart, and then after that, we will look at pressure.